Well folks, here's another radio. Now this gentleman's a member of our radio club and we've got a meeting on Saturday, so it's Friday today, so I better get this done or else. We've got a Lake 850 Manxman, and you all know these are a Great GT868, and at the time people would change the M in Manxman for a W, which would give it another meaning. So it's a bleed over box, but it's a 3.5 watt radio, but they're usually reliable, and in a rural environment they usually work well. So this gentleman owns a car repair garage. He's a full amateur license user, but he does enjoy having CB radio as well. And somebody came into his garage and said, "You're into radio, aren't you? Do you want this?" So he said, "Oh yes, please." So it's a customer gave it him, and we will run through it. So it's come with a mic, standard replacement mic, but the original mics were this style. So it powers up, and we'll put it on channel 20. It's in PA at the moment. Make sure that's up, make sure that's down, and we'll plug our speaker in. Wish I knew which it was. One two one two, testing 1 2, testing 1 2, testing 1 2, 1 2 1 2, 1 2 1 2 1 2, and you have no control over the volume. This is one of the inadequacies of the Great chassis. Isn't that wonderful? Right, we'll plug the test equipment speaker in. I'll get a sheet of paper and we'll go through what it does. Right, I've got myself a piece of paper. And we put picture on picture on, and we'll see what it's doing on transmit. I'm on the 3 watt scale, so full scale deflection is going to be 3 watts, and it's just 3 watts. On channel 40 it's 3.05, and on channel 1 it's 2.9. Low power. Let's go back to channel 20. 350 milliwatts. And back to full power. See what the current is. 709 milliamps, that's sufficient. Deviation, wallow. I think that needs to come down. We won't be doing the VCO unless it exhibits problems, and let's see how far on frequency it is or not. They're usually pretty stable. Just see which one I want. That one. You know what, that doesn't need touching, does it? It's slightly high. 27,79131. It should be 125, and they drop with age. So that's going to have seen service at some point in the last 40 years, or it wouldn't be as high as that. So with that in mind, we'll now set the signal generator to the correct frequency of 27,79125. I don't need to set it wrongly because that's absolutely on the money. These are as wide as a barn door, so there we go. Can we hear anything? Yeah, we can. So put the cyanide meter on. Let's go over to the cyanide meter. Put a bit more volume on, make sure the RF gain's at full. So the 12 dB is doing 4 microvolts. The 10 dB is doing 3.2. And if it does 20, it just does it at 1 microvolt. Squelch. So squelch full. 30, it's coming in at 24 microvolts. I'd like it to be 100, but that's just what I'd like it to be. Put this to the threshold. Bit of noise at the moment on that control. That's not that brilliant, that's 1.4. Might be alright round scratchy corner. Let's see if we can improve that. See what the S meter reads. And it's well over the top. For S9 it's 23 microvolts. That's really naughtily generous, isn't it? Now whatever power it's doing, it should read 4 on transmit. And you know what, it reads bang on 4 on transmit. That's psychological. If the radio was doing 2 watts, we'd still set the meter to 4. We'll come back to those. That's fine, and we know the sockets work, and then we know the mic works. So let's get it opened up and get on with it. As ever, I've got a limited time. But I'm waiting for a couple of parcels to be dropped off, which have been kindly donated by one of our regulars, Jamie, the licensed radio amateur. That screw isn't going to come out. So that needs replacing. So a complicated receiver to set up. And I have done a few years ago the textbook method, which is using a sweeper generator. I did this on our other test bench behind me, but we usually use the cyanide meter to set it up. So it's certainly one of the better, electronically one of the better ones. So we don't need to go in here. The frequency adjustment is the right hand corner inside that screening can, but we don't need to touch it at this moment. So they've been carefully blue and redded. Can you see that? No, you can't. It's somebody's written on black and red, B&R, not blue. What am I on about? But that might not be the right polarity, so we'll see. It doesn't matter, but it's like it would with stereo, but I do like it to be right. See what the speaker says. Well, the plus is to the right, so that doesn't look right. So while we're thinking about it, get the meter out, get it on continuity. chassis. Don't even know if chassis is negative on these, or is it floating? Let's see. Oh, I'm not going to get anything with the extension speaker plugged in, am I? So I've got, so the black is negative, so the way it's been labelled is, as I guessed, the wrong way round. So I've gone to all that trouble and then it's wrong. So, quick tune-up. So we start on transmit up that way. Don't touch that one when it's fitted. That's done with the spectrum analyzer. That one just there, and that's not supposed to have a core in. So this radio is already doing 3 watts, but the service manual says they're supposed to do 3.5 watts. The service manual also says any radio doing more than 1.7 watts is working properly. So don't chase faults that aren't there. Right, so we'll make sure we're on channel 20, we'll actually turn back on, and let's go into transmit and see if we can coax a bit more. I've switched to the 30 watt scale, let's put that up on the inset picture. So 3 watts we've got. Need to make sure it's balanced because it wasn't quite within the limits. You really want it within 0.1 between channel 1 and channel 40. You know, like you've got 3.9 watts on channel 20. You don't want it to be more than 4 on channel 40 and 3.8 on channel 1. So you want to get it as balanced as possible. Hopefully 4 watts right across the board, but that's not usually that common to be able to achieve on any radio. Oh look, that one was out. We're now just over 3.5. Unkey for it to cool down. Hey, we're going to have a 4 watt GT868. It's been known before. That's doing more than most new sets will do anyway. You know what, that's 3.95. Wow. So I'll tell you what I'm going to do, I'll just do deviation on the test set behind me. It's the preset just there. First, I'll tell you what, first of all I'll set it on here, and then we'll verify it on the other test set, and then at least you can see. Wallow. So this, I can't trust the transmitter deviation meter on this test set. It's got some iffy capacitors, and sometimes it's spot on, and sometimes it isn't. So we'll check it with the test set behind me. Wow, that's spot on. So today it isn't playing up. You know, I might be able to do the whole set in the limited time I've got. So 2.2 to 2.5 kilohertz, that's going to remain the same. Drop slightly, which is even better. So back to transmit power. So we'll say 3.9 watts on channel 20. 3.8 on channel 40, 3.9 on channel 1. When we do the on the air test on channel 31, it'll be at its worst point, won't it? Check low power back on channel 20. .320 milliwatts. That's dropped, which is strange, but it's dropped. And then we'll check the current consumption now on full power. It's 0.849, still very efficient for a 4 watt output, or approaching that. Little bit of noise on that, on the volume control. A little bit of noise on the squelch control. A little bit of noise on the RF gain control, and we won't worry about the dimmer. So that deviation, with it being 4 kilohertz, you know, you'd be causing bleed over on channels either side with this, which if you're listening to another set with crummy receive like this has, you won't notice. But if you do it to something with crystal filter, it'll be very distorted. Right, we'll go through the receive, and the detector isn't normal. We'll go to the oscilloscope, we'll turn the volume up, and we'll do the pink one and the blue one. So you can see that's made a massive difference. Now the pink one. We'll do that with the cyanide meter. So the clarity's just improved amazingly. One day we'll do a scratchy corner test before and a scratchy corner test after, and you'll just see the difference of servicing sets. But it's time, isn't it? It's having a set on the bench for 2 days to do that. We can only do one on the air test per day, and it needs to be between 7 and 8 o'clock to fit in with Mr. Chippy's work pattern. So, let's go over to camera 4, which is that one, and I will drop the attenuator on the signal generator. I'll have to turn the volume up. These sets are a bit more like an AM set in the way they, oops, just turn the squelch down as well, in the way they have quite a quiet background noise. Start with the front end here. Slight improvement. Slight improvement again. That was already spot on. I'd be no good as a garage mechanic, would I? No, it was already spot on, mate. There we go. Done. Be so careful with this pink one. It's the shape of the recovered audio. Really have to be very careful. Let's see what we've now got on receive. Turn the volume up accordingly so we can get the meter to read properly. So I would say that's 12. We're now 0.44. And that's worse, but bear in mind we've got the detector right. And you can often find that with the detector out, you've got more sensitivity, but then you can't hear them because it's distorted. 10 dB, 0.37, 20 dB, 0.85, because the noise has come down. Squelch. So I want that to come in at 100 microvolts, so we'll adjust that. Now then, I think it's the front one. One's meter and one's squelch. That's meter, so it's the back one is squelch. Right, 100 microvolts is where I want it. Let's put the attenuator up on here. So we've now got 100 microvolts for tight squelch. Now hopefully the sensitivity of the squelch has now improved because I've corrected the detector. So let's see. So set the radio squelch to threshold with the signal generator on standby. Switch the signal generator back on, parked at 0.3 of a microvolt. Now I heard that pop in, it didn't do that before. There we go, that's better. 0.88 microvolts for the squelch. That's just what we wanted to happen. That's really good. It's got better than most set sensitivity, and this can be the undoing of these type of radios. This is half of the problem. They're a bit too sensitive for their own good, especially with the lack of filtering. So we'll do the S meter, 100 microvolts on the signal generator, and we'll set the S meter accordingly. So there's S9, which is where it should be. And squelch is still right, so I didn't disturb that. Transmit meter, I didn't do that, did I? So I want that to read 4, regardless of what it's doing. And it is. They were all done, that's it. No repairs needed, just that bit of a retune. And another 0.9 watt out of it. So luckily these sets don't tend to get played with them not being having much street cred. So the one which says red is the black wire, and the one that says red, I don't know what solders they've used here, but I think they've used plumber's solders with no flux. So we'll just tin the wires. So we'll put red to where it says black because that's the positive. And black to where it says red because that's the negative. Then we'll have the speaker actually the right way around for the first time for decades, no doubt. We might actually hear somebody on these with them being more sensitive than most sets. Well, Steve will be pleased. So the golden screwdriver had turned the deviation to 4. So let's all clap the golden screwdriver expert. That's just kicking around the screw, so that can be there. We'll take it off the test gear, take it off the test speaker. Now if you have a noisy vehicle like a diesel, these are not an ideal radio to be having, because the amplifier for the receive is only 1.5 watts. To be honest, you do need 2.5 watts of audio on a CB, so at least you can plug an extension speaker into this model, which is one of the few greats that you can. Even the Fidelity 1000 is 50-50 as to whether they have an extension speaker or not, and I don't think any of the 850s have. So, or the 858s. I'm looking for what? I'm looking for turning the power off to the test set and everything, and plugging in the roof aerial, which is the Antron 99 without the optional ground plane kit, and mounted just above gutter level of a single-storey building, broadside into a concrete tiled apex roof. Deliberately done so as it's not that good. Okay. One Nano Roger. Well, we've got the music players, so that'll be Nottingham. Oh, it's a logical song. One Nano Roger. So you see, now we're on an aerial, we get less on the meter than we did on the dummy load. It doesn't mean the radio is doing less. Just as if it's banging across doesn't mean it's doing more, because it's relative to SWR. Unlike new sets, which are mostly pre-programmed to just whop across and make you think the radio's transmitting, even when it's not. So there you have it, Steve's late 950 Manxman from 1981. Which I've no doubt he'll be very chuffed with. Thanks for watching.